Class. As I told you, you are going to have a video today. I've got jury duty one more day well, actually, I got jury duty until spring break. So you got your video today. Today's lesson is over Module 8, or I'm sorry, Module 4, Lesson 8. Lesson 8 is percent error. It should start on the page after your homework. I believe our homework was on page S53, so this should be S54. For those that do not have their book, you need to make sure you take these notes. There's not that many problems. You can take all these notes. You will be graded on the completion of your notes when I come back tomorrow. So try me. Do not come in here with your notes completed on Wednesday, and you'll see what happens. Play around with the substitute today. I will let Mr. Hardaway know that you are to be removed from class. Do not mess with the sub today. You've got way too much work to do. You have a test coming up. You cannot afford to be playing around and goofing off. Okay, that includes you, Mr. Miller. That includes you, Mr. Johnson. That includes you, Mr. Jenkins. Let's see, that also includes Keneal, Takavion, Cameron. You know who you are. You know the ones that goof off way too much. Lariah, talk about you too. We expect better out of you while I'm gone today. All right, so this is your first problem. This is your bell work. Substitute, if you do not mind. On the table there is a stack of papers, each one labeled with a classroom. I need those bell worksheets passed out to the kids so they can go ahead and get started on their bell work problem. Which expression is equivalent to 12/5 x minus 2? Now, I'm going to give you all a couple minutes to try to figure out the problem. Remember what I said? You're going to get about maybe 3 to 5 minutes, so I'm going to go ahead and flip the timer. Now, if you're struggling, remember, equivalent means equals. If you took a value such as 1 and plugged it in for x in every single one of those expressions, if it is an equivalent expression, it should come up with the exact same solution every time. It should be the same answer. Now, looking at the problems, I would plug in 5 for x. 5 for x. Everywhere you see an x, I change it to a 5. So it would be 12/5 times 5 minus 2, just if I was you. All right. Now, it should have just taken you a couple minutes. You should have sat there and looked through the problems, and you should have come across a solution. If you have not, this is your opportunity to be paying attention and listening carefully. So, in this problem, it says it's 12/5 of x minus 2. Now, normally, when you're looking for an equivalent expression, you're looking for an expression that looks similar. Now, we kind of got a little bit of a curveball thrown to us. We got 3 problems with the distributive property, which means we got to do a little bit of multiplication. Now, this problem here, if you wrote it out correctly, would be, let me go ahead and change pen because, Mr. Hale, he likes a certain pen. Oh, then let's go let's make this a full screen for you. All right, so we've got, if we simplified this out, if we wrote this out the correct way, this is 12x divided by 5 minus 2 divided by 5. Now I know that doesn't look the same as the one that's above, so let's move the x to the outside so we can actually see it. That's 12 fifths times x minus 2 fifths. Is that the same as the one that's up the top? No, so that's not equivalent. Now if I use the distributive property here, 2 times 2 fifths, that's 4 fifths x minus 2. The 2's match, but not the coefficient in front of x, so B cannot be correct. All right, 2 times 6 gives me 12 fifths x minus 2 fifths times 1 is going to be 2 fifths. Is that the same as the one that's at the top? No, it is not. So that leaves only one possible answer left. It's going to be D. Remember, the distributive property is the key for this problem. You have to take the number that's outside the parentheses and multiply it by each number inside the parentheses. So this would be 1 fifth times 12x minus 1 fifth times 10. And a fifth of 10 is 2, and a fifth of 12 is 12 fifths. Okay? All right, so what are we doing today? Today we are talking about percent error. Okay? All right, so percent error, what we're talking about with this problem, the stake that's at hand, is we're looking at how far somebody is off from the correct measurement. Okay? Or how far somebody's off by the correct numbers. Say, for example, I measured this, table 2 here, and I measured it to be 5 feet and 18 inches long. Okay? And then somebody else comes along and measures it at 5 feet 8 inches long. We take the time, we actually measure it, turns out to be exactly 6 feet. Well, we're both off. The question is, how far are each of us off in terms of a percentage? One could be off 10 inches, the other's off 8 inches. So we know one's closer than the other, but the question is how much of a percentage are we off compared to what the actual measurement is? Okay? So you got 3 students here, Taylor, Connor, Jordan. They each measure let's say a notebook. First measurement was 15 and 2/8, 15 and 4/8, 15 and 4/8. The second measurement was 15 and 3/8, 14 and 7/8, and 14 and 6/8. Now, the question is asking us to find the absolute error of the following problems. Absolute error is actually a pretty simple thing to find. It's the absolute sign of an a minus x. That's the expression. The absolute value of a minus x. Now, it really doesn't matter the order in which you put these in, but if I was going to put them in and I was going to put them in correctly, I would most likely be subtracting the first measurement from the second measurement. No, it looks like I cut something off. I'm sorry, guys. Here we go. The class discusses the dimensions of a computer's monitor size. The length of the diagonal screen tells us discussion. Select 3 students to measure the diagonal of a 15-inch screen using a ruler. Okay, so a sample list of each student's measurement is recorded below. If a 15-inch monitor is not available, use another size. If not, a computer is available, represent the sample data below. Okay, so I'm not here, so we don't have a computer. So these students measured a computer monitor, and the computer monitor was 15 inches. So this is the actual measurement. This is the actual length. So this is our A. These are our experimental measurements, or our X. So we're going to do A minus X, and we're going to do the absolute value of this. Okay? So Taylor's measurement, his first was 15 and 2/8. The actual measurement was 15 inches, so we're going to do the absolute value of 15 minus 15 and 2/8. Okay? 15 minus 15 and 2/8. All right, 15 minus 15 and 2/8. Okay, well, 15 minus 15 is going to cancel out, giving us a 0. So that's an absolute value of a negative 2/8. Absolute value makes everything positive, so this is just 2/8. So it's a 2/8 of an inch off, or you can simplify it and say it's a quarter of an inch off. Okay, that's his error. His error was a quarter of an inch. All right. So let's see, Connor's was 15 and 4/8. So let's look at Connor. Both Connor and Jordan both had 15 and 4/8 of a difference. All right, so Connor So Connor's measurement 1 was 15 and 4/8. So we're going to take absolute value of 15 and 4/8 minus 15. 15 and 4/8 minus 15 leaves us absolute value of 4/8. The absolute value of a positive 4/8 will be 4/8. So they were 4/8 of an inch off. But now, can I simplify that? I can. That would be a half an inch. Now, part C says Jordan's measurement for 2. Well, let's go back and take a look at Jordan's measurement for 2. Jordan's second measurement was 14 and 6/8 of an inch off, or 14 and 16ths of an 6/8 of an inch. Oh my goodness gracious! All right, so 14 and 6/8 of an inch. So we're going to do the absolute value of 14 and 6/8 of an inch minus 15. Okay, so we're going to come over here to the side. We're going to do 15. Now 15 can be written as 14 and 8/8. Now why are you doing 8/8, Mr. Hale? Because this fraction has a denominator of 8. So I'm borrowing a whole from 15 to make it a whole of 8, make it a fraction of 8/8 minus 14 and 6/8. Well, 14 minus 14 is 0, so 8 minus 6 gives me 2, so it's a 2/8 of a difference. So Jordan's measurement was an absolute value of 2/8 of an inch off, or he was 2/8 of an inch off of his correct measurement. So if you simplify 2/8, you get 1/4. So 1/4 is your answer again. Now, these are just absolute errors, okay? What was the distance they were off? All right. Now, this is going to help us when it comes to the next part of our problems. Our next part is percent error. Percent error, again, is nothing more than just a formula. I know it seems like these problems are a little difficult. Why are we doing this, Mr. Hale? Well, you're about to find out why these problems get a little bit more in depth. All right, so let's move on to the next problem, or the next part. All right, so example 2, how right is wrong. So we're going to find the percent error for Taylor's measurement 1. So percent error has a similar formula to absolute error. Percent error is going to be A minus X over the absolute value of X. Okay? Now, let me read you the definition for absolute or percent error. The percent error is the absolute value, the percent error is the percent the absolute error is of the exact value times 100%, where X is the exact value of the quantity and A is the approximate value. So A represents the approximate value, and X represents the exact. Okay? So A is going to be what we measured, X is going to be what the actual real measurement is. Okay? Now it says find the percent error for Taylor's measurement 1. What does this mean? Okay, so here we go. So Taylor's measurement 1 was 15 and 2/8. This was his first measurement. So to find the absolute value of, my gracious, I'm sorry guys. These are starting to get mixed up for me. I apologize. All right, to find the percent error for Taylor's measurement 1, we're going to take the absolute value of 15 and 2/8. That was the approximate value minus the actual value, which was 15 inches. And we're going to divide that by the actual distance of 15 inches, and we're multiplying that by 100. So 15 and 2/8 minus 15 gives you 2/8. We're going to divide that by 15 and then multiply by 100. Now, 2/8 simplifies to what? Right, 2/8 simplifies to 1/2. So if I was in your calculator, I would just type in 0.5 divided by 15, and I'd get a decimal. Then multiply that decimal by 100, and you find out that Taylor's measurement was only 3.33 repeating percent off. Okay, that's how much he was over. He was only 3.33% off of the actual measurement. All right, so that's not bad to only be 3.33% off. Now, what does this mean? It means that when Taylor made his measurement, he was off of the actual measurement of the computer to monitor by 3.33%, or 3 1/3%. That's what it means, okay, that his measurement was only off by 3 1/3%. All right, so part B. For example 1, part B, find the percent error for Connor's measurement. What does this mean? Okay, now you should be looking back in your book. What was Connor's measurement? All right, Connor's measurement. Oh, okay. So if you go back to part B, you find out that Connor's measurement error was a 1/2 inch. Okay. If you go back to part B in example 1, Connor was off a 1/2 inch. Well, we already know since this 1/2 inch represented the absolute error, okay, you can say that the formula that we've been using was the absolute error divided by the absolute value of x, or the exact value. So instead of doing all that top work, we've already found all that work from the previous problem. So now we can sit here and go ahead and do our formula a little quicker. So we got a 1/2 inch, which was 0.5, divided by 15, multiplying it by 100. Okay? Well, that's the exact same thing as the previous part A, so we get the exact same answer. 3 and, let's do this one as a fraction for you, 3 1/3%. That was his error, 3 1/3%. All right, this means that Connor's measurement of 15 4/8 of an inch has an error that is 3 1/3% of the actual value. All right, so part C. Find the percent error for Jordan's measurement 2. What does it mean? All right, so Jordan's measurement for part 2, okay, according to example 1, was 0.25 inches, or 1/4 inches. So that's his absolute error. So that's what we're going to be using in the numerator. 0.25 divided by 15 times 100. Okay, so 0.25 divided by 15 gives us a very weird, interesting decimal, but we're going to multiply that by 100, and we get 1.66666, or we get 1 2/3 of a percent. So 1 2/3%. That's what we get. So that's our percent error. Now, I know you're saying, Mr. Hale, this is like, you're going really fast. This is not really easily explained. You're right. It's not a very easily explained set of problems. But the formulas are on the board, on the dry erase board. That's where I left them at. Okay? And I'll even write up there again for you and let you see it. A is the measured value. We'll say measured. Okay? This is what you measure. Whereas X measures the exact value. Okay? This is what its actual measurement is. All right? You're the one that's going to have error. All right? When you measure, when you do the volume and that kind of stuff, you're the one that's going to make the mistake because we're not perfect. Since we're not perfect, we make errors. So think about it that way. A is what you would measure. It's your mistake. Whereas X, it's perfect. It's always the right answer. It's the exact value. All right, so if you get that, you can start making these problems a little easier to do. All right, let's go ahead and go to the next page. It's the last slide. So a real estate agent expected 18 people to show up for an open house, but 25 attended. Okay, so it's asking us to find the percent error. So remember, the percent error is the absolute value of A minus X over the absolute value of X times 100. Well, A and X need to be defined. What does A equal and what does X equal? So A is the measured value. It's what you expect. It's what you found. Well, the real estate agent expected only 18 people to show up. That's what he expected. Now, the exact value is the number of people that actually attended. It's 25. So that's what the answer. That's what our A and X are going to be. A is going to be 18. X is going to be 25. And then we'll be able to find our answer from there. Okay, so if you've set up your problem so far, you should have absolute value of 18 minus 25 over the absolute value of 25, sorry, that shouldn't be a parentheses, that should be a line, times 100. Mr. Hale, how did you know how to set that up? Remember what I said. A is what the measured value is, the approximate value, what you think is going to happen. That's A. X, that's the exact value. That's what really happened. Okay? Then all you got to do is just plug in A for 18 for A, 25 for X, and then you put 25 twice. So you get 18 minus 25. That would be a negative 7 over 25. Well, the absolute value of a negative 7 is going to be 7. So it's 7/25 times 100. So that's when you use your calculator again. 7 divided by 25 gives us a decimal of 0.28. We multiply that by 100 to get our percent. So we get 0.28 times 100 gives us 28%. This goes to that. So his error was 28%. Now, let's say this real estate agent made cookies based on what he thought was going to show up. Did he have enough cookies? No, he probably didn't have enough cookies for everybody. So he came up short by 28% because that's what his error was. His percent error was 28%. He estimated 18, 25 showed up. He was 28% off of what the actual measurement was, how many people actually showed up. Part 2, or number 2. In science class, Mrs. Moore's students were directed to weigh a 300-gram mass on the balance scale. Tina weighed the object and reported 328 grams. Okay, so again, we need to use our percent error formula. A minus X, the absolute value of that, over the absolute value of X, times 100. What is A and what is X? Okay, A is what the measured value is. What did she get? Well, she got 328 grams. The exact value of the weight is going to be 300 grams. Okay, that is scientifically proven. Okay, when you are given a mass that's 300 grams, it's not going to be 28 grams off. So Tina's made a mistake. She's weighted heavier than what it is. Now that could be because she accidentally had her sleeve on it or something like that. Many things could make adjustments like this. So we've got our A, which is the absolute value of 328, minus our X, which is 300. Close the absolute value signs, divided by the absolute value of 300. All right, and then that's multiplied by 100. Well, 328 minus 300 is going to be the absolute value of 28 over 300. Well, that's just going to be 28 over 300 times 100. Don't forget about the 100. Yes, I took it out in the middle part, but we don't want to forget about it at the end. So 28 divided by 300 equals, all right, you get a nice little decimal again, so we're going to times it by 100, and we get a percent error of 9 1/3%. Mr. Hale, why do you keep on doing fractions? Because I don't want to keep on writing a repeating bar above the number. All right, a fraction represents that repeating decimal. 1/3 represents 0.333333333333. So it's easier just to write a fraction percentage instead of a decimal percent. All right, so let's look at this last problem down here at the bottom, and then we're done. Darwin's coach recorded that he had bowled 250 points out of 300 in a bowling tournament. However, the official scoreboard showed that Darwin actually bowled 225 points out of the 300. So what is Darwin's coach's error? Percent error. Okay, so we got to use our formula again. A, absolute value of A minus X divided by the absolute value of X, and we have to define A and X. Okay, now this is Darwin coach's measurement. He's measured at 250. That's going to be our actual. Okay, because the referee, that's the official. That's what you have to work with. That's the exact. We can't sit there. Now, Darwin's coach can appeal the score, but we're not worried about an appeal. We're worried about what the official scoreboard shows, and the official scoreboard says he scored a 225. Okay? Now, it's not whether or not it's out of 300, because that doesn't change. That's consistent. What we're worried about is what was the difference in the coach's score versus what the exact score was. That's why we're ignoring these 300s. All right? We just need to be worried about these two set of points right here. So we've got the absolute value of 250 minus 225 over the absolute value of 225, okay, times 100. Well, 250 minus 225 is 25. So that's the absolute value of 25 over 225 times 100. So what's 25 divided by 225? 25 divided by 225 is going to be 0.111111111. If we multiply that by 100, you get 11.111111. Well, when you see 0.1 repeating, that fraction is going to be 1/9. So this is 11 and 1/9 of a percent. And there you go. This is it. That's all you're doing is using these formulas. It's a simple plug in and solve. But you got to make sure you find the exact value. That X has got to be correct. Because if we, if we had used 250 on the bottom, we would have gotten an entirely different percent. So you got to be careful. You got to use the right percent at the right time. Now, you should have plenty of time left in class. So with that being said, you got some homework. Okay? I'm not 100% sure what page it's going to be in your book, but your problem is going to be, you got problem set. Okay, problem set. It's going to be numbers, let's see. Let's go with numbers 1, 2, 3, 5, 6, 8, and 9. So basically numbers 1 through 3, 5 through 6, and 8 through 9. That's your homework for the night. That's only, what, 2, 4, 7 problems. That's it. Okay? I guess that's it for the morning. If you're able to complete this in class, by all means, get it done in class. Have yourself done homework. But if you can't get it done in class, this is your homework. It needs to be finished before you come to me tomorrow. Okay? All right. You guys have yourself a good day. I will see you all bright and early Wednesday morning.